In this video, we're going to understand the del operator in more detail. Del operator is a vector differential operator, and this can be seen in Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system. In general, the first what we require is that to understand the del operator in various coordinates. So by definition, del operator in Cartesian coordinate systems is written like this. Del is equal to vector chronicle delta x dou by dou x plus dou by dou y plus dou by dou z plus followed by chronicle delta. That means the direction delta x, delta y, delta z. So let me write it here. The del operator, not delta. The del operator is given as delta x dou by dou x plus, whereas this is vector, delta y dou by dou y, whereas this is vector, plus delta z dou by dou z. So this is the chronicle del operator in Cartesian coordinate system, whereas this is vector. In cylindrical coordinate systems, see, first, if we understand in the cylindrical coordinate systems, what is the differential length we found, then it is very simple. It is actually a part of dr plus. See, this dr doesn't stand alone. This should be followed by a unit vector. And then you have r d theta. Again, there will be direction to be shown plus dz. If these things are known, writing del operator is a t-scale. That means del is equal to, you have here r, so dou by dou r, of course chronicle delta r, plus here you have r d theta, so dou by dou theta 1 by r, dou theta plus dou by dou z chronicle delta z. So this is how we can write the del operator in cylindrical coordinate system. Similarly, you can understand what is given in spherical coordinate systems. The differential length would be the sum of dr r d theta r sine phi d phi. So how do we write del operator in spherical coordinate systems? So we are looking at the del operator as it is the del operator in Cartesian coordinate systems. First one is Cartesian coordinate systems, cylindrical coordinate systems, and spherical coordinate systems. So this is written in spherical coordinate systems. So del, this is the definition of, this gives the definition of the del operator. So once we understand how to write the differential length in what are the different terms you have, different lengths we follow, and now we are ready to write the del operator in spherical coordinate systems? Very simple. First you have dr, so I write dou by dou r plus you have r d theta, so 1 by r dou by dou theta plus you have phi 1 by r sin phi d phi. So this is, sorry, dou by dou. So you need to add the conical delta term, that means which shows the direction. Dou delta, delta theta, delta phi. So this is a conical, what you call del operator in. So overall, what we have seen in this as of now, del operator in three coordinate systems. Okay. Now comes, the del and this. If I write like this is, what does this imply? Let us go. This is known as gradient or gradient of a scalar. Gradient of a scalar. So you have a scalar quantity and you have derivatives, and once you actually take an operator for it, that means is known as so this is known as gradient of a scalar field. So how does a gradient of a scalar field is written? The vector thus constructed, you can see the definition here. The vector thus constructed from the derivatives of s is designated as del s. So let me take into the three directions of this. Okay. So del s, suppose say we are writing in terms of Cartesian coordinate systems. Cartesian coordinate systems. So if I say del s, okay. So this we can write it as dou by dou x. This is delta x plus delta y dou y plus delta z dou z brackets. So what will happen directly? It is by definition derivatives of s. So how do I get the derivative of s here? Below. Yeah. Now you can see simply write separately. There is no operator between del s, right? This becomes del s by dou x by dou x plus dou s by dou y plus dou z dou s by dou z. So now come to this place. Okay. Yeah. Now come to this place and observe what is written here. This is in the x direction or the x component. Now what happened is del s is now a vector. This is a vector which is constructed or which is obtained. We have seen by definition constructed from the derivatives of s, right? So this becomes the vector, and the above portion, what you are seeing here, these three are the x component, y component, and z component of this vector. So generally, when I write in del s, what is that I have written? The vector from del s, dou s by dou x, plus dou s by dou y, plus dou s by dou y. So you can see the components. X component is this, y component is this, z component is this in Cartesian coordinate system.